Today we are going to talk about sequences and equations. A sequence is an ordered list of numbers. You've seen sequences before, but let's go ahead and get that down. So even if I said something like 1, 2, 3, 4, 5, ... that's a sequence. It is an ordered list of numbers. I could also do 2, 4, 6, 8. That is another sequence. Today the types of sequences we are going to take a look at are called arithmetic sequences. An arithmetic sequence is a sequence in which the difference between any two consecutive terms is the same. Let's write that down and then dissect it. So it is a sequence in which the difference between any two consecutive terms is the same. So let's just look at this here. We're talking about a sequence, so we have an ordered list of numbers in which the difference, that means we'd be subtracting to find the difference between any two consecutive terms. Those are terms that are next to each other, is the same. So for example, 3, 6, 9, ... This is a sequence. It's an ordered list of numbers. The difference between each of these is 3, and it happens to be the same. So this is in fact an arithmetic sequence. What we are going to do today is create rules, just like we did with X and Y tables in a previous chapter, to describe what's happening with an arithmetic sequence. When we come up with that rule, we can write an equation that can help us predict future terms. So what does that look like? Well, let's take a look at an example. So I'll ask you to describe the sequence using words and symbols. So describe using 1 words and 2 symbols. So let's look at a very basic one. 6, 7, 8, 9, ... Well, the first thing we can do is organize kind of like an X, Y table. It doesn't matter what variables you choose to use. You can use N, T's, X's, Y's, but we do need to make sure we understand what those variables represent. So, term number and term. The term is what has been given to us. So what has been given? We were given 6, 7, 8, and 9. The term number always starts at 1. 6 is the first term, 7 is the second term, 8 is the third term, and 9 is the fourth term. So that's how we create our X, Y. So if we were using X and Y, I could do that. Or if we're going to say the term number is represented by N and T for term, we could do that as well. Again, it doesn't really matter as long as you define it and use your own variables. So let's take a look here. To get from 1 to 2, 2 to 3, 3 to 4, we have a difference of 1. Pretty basic. What about getting from 6 to 7, 7 to 8, 8 to 9? Well, there again, we have a difference of 1. So it turns out that the terms have a common difference of 1. Let's write that out because we need to describe this in words. The terms, and again I'm talking about right here, the terms, not the term number, have a common difference of 1. So how would we describe this in symbols? Well, in order to figure that out, we need to know what's going on between the term number and the term. So here's where we want to find a relationship. You might need to guess and check a little bit to figure out the relationship, but basically you want to figure out how do you get from 1 to 6? How do you get from 2 to 7? From 3 to 8? From 4 to 9? Well, from 1 to 6 you could add 5. You could also do what's, I don't know, 1 times 2 would give you 2 plus 4, so maybe times 2 plus 4. These are different things to try out. What you want to do though is see if any one of these or another one that you come up with follows true for all of the pairs. You know, does plus 5 work with 2 and 7? Does times 2 plus 4 work with 2 and 7? Well, it turns out that plus 5, 2 plus 5 is 7, 3 plus 5 is 8, 4 plus 5 is 9. This one works. 2 times 2 plus 4 would not give me 7, so this one doesn't. But that's where the guess and check comes in to figure out the rule. So in words, I can also say that the term is 5 more than the term number. So I've described what's going on here in this arithmetic sequence. Now, how can we use our symbols of n and t? If n is the term number and t is the term. Well, I can use this statement here. The term is 5 more than the term number. So the term is represented by t, is, and that's my equal sign, the term is 5 more than, means addition, than the term number n. So this would be my equation, or how I use symbols. If you were using x and y, it would look like this. Y equals 5 plus x. You could also rewrite it as f of x equals 5 plus x. Again, a lot of different ways to write it, but they will still give us the same situation. Let's go ahead and try another one just to see it again. So same directions. This time we're looking at a sequence of 7, 10, 13, 16, ... Okay, so we're going to describe what's going on here, write an equation to express it, and then we want to find the 15th term. Because again, what's the point of using an equation or coming up with an equation if we don't use it? So we will use the equation in this piece. When we're setting this up, we always want to start with our term number and then our term. Term numbers are always going to go in order starting at 1. So our first term is 7, our second is 10, third is 13, fourth is 16. So let's just look at the terms. The difference is 1. 1 to 2, 2 to 3, 3 to 4, it's all 1. What about from 7 to 10, 10 to 13, 13 to 16? Can you see it? The difference is 3. Just making sure that there is a common difference so that we can recognize that this is an arithmetic sequence. So now we can say that there's a common difference of 3 between the terms. I'm not going to write that out right now, but that is how I would describe it. And let's figure out the pattern. So again, how do you get from 1 to 7, from 2 to 10, from 3 to 13? We might need to try a few things. 1 to 7, add 6. Okay, well, what's 2 plus 6? It's not 10, so that doesn't work. How about times 2? What would 1 times 2 would be 2 plus 5. We could try that out. That gets you from 1 to 7. What about with 2? 2 times 2 is 4 plus 5. That doesn't work. Maybe I'll try times 3. 3 would give me plus 4 then to get to 7. What about 2 times 3 would be 6. Plus 4 is 10. 3 times 3 is 9. Plus 4 is 13. So that works. So again, a little bit of guess and check. Let me go ahead and define my variables. If I'm using n again for term number and t for term, to find the term t, I would need to take the term number, multiply it by 3, and then add 4. If you're using y and x, y equals 3x plus 4. These are all linear equations. We've worked with these before. So how do you find the 15th term? So go back to whatever variable you're using for term. Here I was using, let's see, 15. So I am going to go ahead and plug that in for n, because again, I want to find the 15th term. And in order to find that 15th term, I am putting 15 in for my term number. I can jump way ahead in the sequence now without having to calculate all the way up to that. 3 times 15, you can use the distributive property. 3 times 10 plus 3 times 5. I know you can do that. Right, 3 times 10 is 30. 3 times 5, You got it? Okay, and then you need to add 4. Do you have it? Okay, so t equals 49. And then same thing if you were using y and x. That's what it would look like here. So the 15th term is equal to 49. And then I could ask you, what's the 100th term? And again, you can plug it into the equation to find that 100th term. I'd like you to practice just a little bit now, so if you could grab your handout on page 14, I would like you to go ahead and try numbers 11 and 12. So pause, work through those, and when you're ready to see the solution, hit unpause. Okay, so for number 11, here we go. This is with the sequence 26, 29, 32, 35, and we have to find the 57th term. We can write an equation that looks like this. The term is found by doing 3 times the term number plus 23, and you should get t equaling 194 when you plug in 57. With number 12, this was 112, 140, 168, 196, and we're asked to find the 74th term. We get t equals, this one was tough, 28n plus 84. This one was pretty tough. Were you able to get this one? When we plug 74 in for n, we do get t equaling 2,156. So that's a little bit trickier, but I definitely believe you should have gotten number 11. Let's take a look at another one together, number 13. So please read that one. Read along with me while I read it out loud. So it says, Louisa ran 3 miles on the 3rd day of a month, and she repeated her run every 4 days for the rest of the month. What equation describes the sequence of days of that month that Louisa ran? Well, again, we want to be thinking in terms of term number and term. We're not asked for a total number of miles. I know your first question might be, well, which month is it? How many days are in the month? And honestly, that does not come into play. Let's think about what's going on. First, I know that my term numbers are 1, 2, 3, 4. Maybe I'll start there. And I will say, well, when did she run first? On what day did that occur? Well, that occurred on the 3rd day, right? And then I want to know, well, when did she next run? Because that's what I'm looking for here, the sequence of days of that month that Louisa ran. So it says she repeated her run every 4 days. So what's 4 days from the 3rd day? Well, that would be the 7th. And what's another 4 days from that? That would be the 11th. What's 4 days from that? The 15th. So as you can see, I'm not focused on the fact that she ran 3 miles every time, and I don't need to keep going until the end of the month because I can already see a pattern. Here, again, my difference in term number is just 1. What's the difference of my terms? Well, it's every 4 days. So how can I write an equation to express this? Well, again, if I want to use maybe n for term number and t for term, I want to find a pattern. How do you get from 1 to 3? 2 to 7, 3 to 11, etc., etc. Please pause and figure that out and unpause when you're ready to see the solution. Okay, so we can find t by multiplying the term by 4 and then subtracting 1. 1 times 4 is 4, minus 1 is 3. 4 times 2 is 8, minus 1 is 7, and 3 times 4 is 12, minus 1 is 11. So this one works. I will see you in class. Thank you very much.